Okay, now let us learn about electric field. Okay, so what is electric field strength? Electric field strength has two names. You can either say it is actually three. Yeah, you have three names. It's either electric field. Sometimes people call it electric field, or some people call it electric field strength. Sometimes people say it is electric field density. Electric field density. So they are the same. Okay. Sometimes I also heard before people say electric field intensity. So all these refer to the same thing. Okay. Electric field strength, electric field density, electric field intensity. So they are the same. And the formula is given by E equal to electric force over test charge equal to KQ over R squared. Actually, this is similar to the gravitation. If you still remember, let us look back to our analogy. Okay, so we already learned about gravitational force. Gravitational force, Gm over R squared. So we have, in this chapter, we have electrostatic force, KQQ over R squared. You just change the G into K, the mass into charge, and distance is the same. Yeah, distance between the two mass, distance between the two charge. So last time we have gravitational field strength or acceleration due to gravity. Now we have electric field strength. Last time we have gravitational field strength. Now we have electric field strength. Last time it is force over mass. Okay, force over test mass equal to Gm over R squared. This is point mass. Now we have maybe I should write it down. Last time we have divided by the test mass. Okay, divided by test mass, and the Gm over R squared, the big M, is the point mass. Now we divide by test charge. We divide by test charge and left over with point charge. The difference is just mass and charge. Mass change to charge. It's still the same test charge and also the point charge. You see that? It's the same formula. Same formula. So it is a force over charge, force per unit test charge equal to KQ over R squared. You see? And last time it is because it is mass, force over mass, so Newton per kilogram. Okay, so the gravitational field strength is Newton per kilogram or meter per second square because it's acceleration due to gravity. Now the kilogram changed to charge. Charge is coulomb. Yeah, actually the unit for charge is coulomb. You know coulomb. Coulomb is the unit for charge. Okay, charge. Unit for charge. Coulomb. So last time is divided by mass. That's why you have per kilogram. Now you divide by charge. So now you have per coulomb. Newton per kilogram. Now is Newton per coulomb. So it's almost the same. See that? So gravitational field strength only depend on point mass. So same as electric field strength, only depend on point charge. It only depend on one charge. Last time gravitational force depend on both masses. Electric force also depend on both charge. But gravitational field strength depend on only one mass, which is point mass. So electric field strength also depend only on one charge, which is the point charge. Okay, and you see, yeah, electric field strength is also a vector because it is a force per unit test charge. Because it is actually force. Electric field strength is actually force per charge. It is actually force. That's why it is a vector. Yeah, electric field strength is a vector. I will explain this later. Okay, you must know that force and electric field strength, both of these are vector. Okay, this is very important. Both of these are vector. Force and electric field strength, both of these are vector. They have both magnitude and direction. Okay. Since it is a vector, you must draw a vector diagram to get the resultant force or resultant field strength, you must draw a vector diagram to find the resultant. And you must also find the xy components because they have directions. Yeah, directions. So you must resolve to x and y component before you can find the resultant. And remember, this is very important. And this one I will explain more during calculation, during the problem solving. Okay, which is when you calculate the magnitude, of either force or electric field strength, when you calculate the magnitude, you ignore the sign on the charge because we have positive and negative charge, isn't it? So for the negative charge, for the negative charge, you ignore the sign. For the negative charge, you just ignore the sign. That means you don't substitute in, you don't put in the sign. You don't put in the negative sign during calculation for the magnitude of force and electric field strength. When you use this formula, KQQ over R square or KQ over R square, if this big Q or small q, they are negative charge, don't put in the negative sign. Don't put in the negative signs during the calculation for magnitude. Okay, ignore the sign. I will explain more in calculation, in problem solving. However, when you doing the x and y components, you need to denote the directions. That direction you need to put negative signs. Especially like going to the left. When you put the value into the table, okay, the direction to the left you must put a negative sign. Direction downward you must put a negative sign. That is when you find the xy components, and you want to use the positive and negative sign to show the direction. You must put the negative sign for direction to the left and direction downward. That is when you calculate the xy component in the table. Okay, but when you calculate the magnitude of force and field strength, don't put the negative sign. If it is a negative charge, don't put the negative sign. Just ignore the sign. But later on, during the scalar quantity, you must have the sign on the charge. This one later on. These are the comparisons. Things which is important. I will explain more later on about this scalar quantity. For the time being, for the magnitude, ignore the sign. But for the direction, you must put the negative sign if it is direction to the left or direction downward. Okay, enough for that. So, okay. So it's the same, Force per unit charge only depend on point charge. Let us look at this one. So what is actually electric field strength? Electric field strength is actually force per unit test charge. So like this. Let us put it simple like this. If the electric field strength is 10 Newton per Coulomb, why is it Newton Coulomb? Why is it the unit Newton per Coulomb? Because it is Newton. Force is Newton. Charge is Coulomb. So Newton per Coulomb. That's the unit for electric field strength. Now, what is it mean by electric field strength of 10 Newton per Coulomb? It means that if we have a positive 1 coulomb of charge, for example, like let's say I have over here I have a positive 1 coulomb. This is actually the test charge. Okay, this is the test charge. Positive 1 coulomb. This test charge, which is a positive charge. It is a positive charge. What happened? Okay, we know that positive, and this one is a point charge is positive. Okay, so we know that positive and positive they repel, isn't it? Positive and positive repel. So this 1 coulomb will experience 10 Newton 10 Newton force. Will be repelled by 10 Newton force. The test charge is only, the test charge is only 1 coulomb, positive 1 coulomb. And this positive 1 coulomb is repelled by 10 Newton force. So, the meaning of electric field strength, 10 Newton per coulomb, that means if the electric field strength over here is, I put it right some more. If here the electric field strength here is 10 Newton per coulomb, okay, I should write. Okay, if the electric field strength over here is 10 Newton per coulomb, okay, 10 Newton per coulomb, that means if I have a positive 1 coulomb over here, it will be pushed by 10 Newton force. So this is the strength of the field over here. If I have 1 coulomb here, it is pushed by 10 Newton. Now, we know that going nearer to the charge, the field strength will become higher, become stronger field, because if you see the line, the closer the line to each other, the higher the strength. For example, like over here, the field strength nearer the charge, the line are closer to each other. That means the field strength over here is higher compared to further away. So I can say maybe nearer to the charge, it has stronger electric field like 50 Newton per coulomb. Maybe I put another test charge, maybe over here, yeah, I shouldn't write there. Maybe over here, positive test charge, positive 1 coulomb. Okay, yeah, positive 1 coulomb. Maybe the field strength over here is 50 Newton per coulomb. Over here, yeah, over here, the field strength is 50 Newton per coulomb. What does it mean? It means that the field strength here is stronger, 50 Newton. That means if I have positive 1 coulomb over here, it will be pushed by 50 Newton. It will be pushed by 50 Newton. It will be pushed by 50 Newton force. Understand that? So we can say electric field strength is actually force for 1 coulomb. It's actually force. Electric field strength is actually force. That's why we know that force is a vector, isn't it? Force is a vector. That's why electric field strength is actually force for 1 coulomb. It's actually the force for 1 coulomb. Like electric field strength of 10 Newton per coulomb, that means the electric field strength is actually the force for 1 coulomb of charge over there. That means for 1 coulomb, you experience a force of 10 Newton. So electric field strength is actually force per unit charge. For electric field strength is actually force. So since force is a vector, so field strength is also vector. It follows the force. It's actually force for 1 coulomb. So over here, the field strength is weaker because further away. So that means if I have 1 coulomb, you only experience 10 Newton force. For 10, that it means by 10 Newton per coulomb. But if nearer to the charge is the line is closer to each other, the field strength is stronger. So if the field strength is 50 Newton per coulomb, that means if I have a positive 1 coulomb over there, you experience 50 Newton force. More force, 50 Newton more force than 10 Newton force, isn't it? That is means by electric field strength, force per unit test charge. Okay, so force divided by test charge. So what left over is only the point charge. So electric field strength depend only on one charge. Which is the point charge. It is the point charge. It only depends on point charge. So electric field strength only look at point charge. It don't look at test charge. Okay, it only look at point charge. So Newton per coulomb. Okay. So direction of electric field only depend on one charge, which is only the point charge, Q, big Q. So you only, unlike the force, you look at both charge, point charge and test charge. If same charge, they repel. Opposite charge, they positive, negative, they attract. But for electric field strength, only look at point charge. It don't look at test charge. If point charge is positive, it going away from the point charge. The electric field is going away. See that? Going away, going outward. But if negative point charge, if it is inward, inward or towards the negative point charge, you only look at point charge. Because the equation, you look at it, the equation only has point charge. Q, the big Q only. It don't have the test charge. It's already being divided away. It don't depend on test charge anymore. Electric field strength only depend on point charge. So when you draw the vector diagram, remember, when you draw the vector diagram, electric field strength only look at point charge, only look at one charge. Yeah, that's very important. I will explain more later on. Now let us look at the electric field strength, electric field diagram. Electric field diagram, we know that electric field diagram, like this one, you have 2-point charge here. The electric field actually come up from positive point charge going to the negative point charge. Positive going out, going outward. Negative going inward. So the electric field diagram, you see, this one asks us to draw the field diagram, electric field diagram. Diagram means you need to draw many lines. It's different from drawing the vector diagram. Electric field diagram means you must have all the electric field lines. Okay. You see, positive going outward, negative going inward. So that's why the electric field line originate from positive, go to negative. And you see, this one is Q and Q. The magnitude of charge is the same. 1Q, 1Q, isn't it? 1Q, 1Q. So you see how many lines coming out? 1, 2, 3, 4, 5, 6, 6, 7, 8, 9. You have 9, sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. You have 10 lines here. You have 10 lines coming out, 10 lines. So here, because you have same charge, you must also have 10 lines. 10 lines. Don't go to draw less than 10, 9 or 11 more than 10, cannot. The number of lines must be the same. You cannot missing one or you have additional one, cannot. If same charge, must have same amount of line. Okay, like look at this one. This one is 1 charge and this is 2 charge. So they must be proportional. The lines also must be proportional. Okay, the field line must come out from positive, go to negative. Okay, you see how many lines the negative Q has? It has only 6 lines. It has 6 lines. How many do you think the 2Q must have? It must have 12 lines. It must have 12 lines. Must have 12. You cannot be. Is it? Let us calculate. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have 12. So you must be proportional. Don't go to simply just write, oh, bigger charge, then I just put 10 lah. Maybe just put maybe put 13. Cannot. You cannot more than 1, cannot less than 1 or less than 2. Cannot. You must be proportional. If the charge times 2, remember, if the charge times 2, the line also must be times 2. If the this is about lines, I'm talking about lines. The lines. If the charge times 2, the line also must times 2. If the charge times 3, then the lines also must be times 3. So for example, like if I have Q and 3Q. So if this one has 5 lines, This one must have 15 lines. How to draw? Yeah, a bit hard. Yeah, normally it's better you draw maybe even number. Don't draw odd number. Yeah, don't draw odd number. Yeah, it's better you draw like this one is 4 times 3. Don't make it too many lines. That you make if times 3, how many lines are there? So it's very hard to draw if you have too many lines. 4 is minimum. Yeah, 4 is minimum. Don't put 2. Don't put 2 lines. 4 times 3 is 12. Don't draw 2 lines only. Yeah, don't draw like 2 lines. How do you show 2 lines? Don't draw like that. Sorry, don't draw like this only. 2 lines. It's hideous. You know that hideous. Don't. Yeah. It's hideous. Don't go to draw 2 lines like that. Minimum 4. Minimum. This is you can say minimum. Yeah, minimum. Yeah. So sorry. Close. So 4. Minimum at least 4 lah. Minimum at least 4. Don't draw less than 4. Okay, that's right. Okay, let us look back. Yeah. Right. It must be proportional. Must be proportional. Okay. Charge times 2, the line also must times 2. And how about this one? Yeah, positive and positive. Positive going out. Yeah, some people draw lines. Yeah. If you know that these two charges they repel each other. So don't go to draw like, you know, the line. I know positive is going out. You don't draw like that. Curve in the wrong direction. Don't curve in the wrong direction. You must curve in the right direction. Curve away, not curve towards. You understand? Don't curve in the wrong direction. Which is wrong. Don't curve in the wrong direction. Okay? Which is wrong. Don't curve. Curve in the right direction. Okay? Curve in the right direction. This is wrong. Yeah? Please curve in the right direction. Now, yeah, here is that means no field here, no field. Now, how about this? The neutral point here, x is neutral point means the field strength here is 0. Okay, and this is a parallel plate. Parallel plate. So how to draw? Yeah. So in the middle is almost parallel to each other. Parallel to each other. But at the edge here is at a certain curve. Yeah, a certain curve because you know is because at the side here no more charge, so that's why he curve outward here. Yeah, at the side there's certain curve, but at the middle is almost parallel to each other. Okay, this is actually uniform electric field. Okay, the difference between the point charge and parallel plate. This one is uniform electric field. This one, like this one, the point between point charge is between the point charge it is non-uniform electric field. Okay, that's it for electric field. Let's stay tuned for the next part. I'm going to explain more on electric field, how to draw the resultant electric field for many charges. Yeah, how to draw the electric field to determine the resultant electric field. Okay, now come on to the next part. Thank you.